When it comes to dividing with exponents, we covered this in the class, but when we divide, we're going to do the opposite of whatever we did when we multiplied. So remember when we multiplied like bases, for instance, x squared times x cubed, we would add our exponent. So in this case, we would add 2 plus 3 to get x to the 5th. When it comes to dividing, we're going to do the opposite. Since division is the opposite of multiplication, what's the opposite of addition? We are going to subtract. So typically we subtract the top exponent minus the bottom. In class, I cover a little trick when it comes to dividing with exponents. Technically, we're not supposed to have negative exponents, and we're going to cover that shortly. So this being homework, I'm going to cover a few problems, and the rest will be done independently. Here we got 5 to the 6th divided by 5 squared. So top minus bottom means 5 to the 6th minus 2. So we end up with 5 to the 4th. Pretty simple. Top minus bottom, nothing major going on. Number 2 is a little bit different. We have 1 over x to the 10th times x to the 7th. Now, technically, x to the 7th is over 1. And when it comes to multiplying with fractions, we go straight across. So top times top, bottom times bottom. So 1 times x to the 7th going across the top means we have x to the 7. And then if I go across the bottom, x to the 10th times 1 means on the bottom we have x to the 10th. So ordinarily we would say x to the 7th minus 10 because it's top exponent minus bottom. And here we end up with x to the negative 3, which technically we're not supposed to have. So because negative exponents aren't exactly happy with where they're at, they want to be where they're not. So in this case, x to the negative 3, technically this is over 1. So I'm going to move my x to the 3 to the bottom. And now that it's in the bottom, the negative goes away. It's thrilled with being in the bottom, so we have x cubed. And up top, now that there's an empty space, we actually have to have something. So we're going to use the magic number 1. So 1 over x cubed. The trick that I use in the class is once we multiply all straight across, for instance, we came up with x to the 7th over x to the 10th. What I do is I ask, where is the bigger exponent? In this case, the bigger exponent is in the bottom, so my variable or answer of stuff is going to be in the bottom as well. So I still have fraction. We're dealing with x's, so x. And we'll do the bottom exponent minus 7. So 10 minus 7. Again, nothing up top, so we're going to use the magic 1. And 10 minus 7 is going to give me 3. So 1 over x cubed. So you could use either method, do it technically correct way, top exponent minus the bottom, and then if we have a negative exponent, swap it to the other side. Or you could use a little trick where it's still bigger exponent minus the smaller, but you do the subtraction where the larger exponent is. In this case, it was in the bottom, so 10 minus 7. Number 3, we have to simplify 6 to the 7th times 6 to the 5th over 6 to the 16th. Separate bases means we add, so we end up with 6 to the 12th over 6 to the 16th. And just like before, the bigger exponent is in the bottom. So if I want to make my life a little bit easier, where I keep all my exponents positive, I am going to be doing the math where the larger exponent is. In this case, the larger exponent is in the bottom, so we're dealing with 6, and it's 16 minus 12, nothing up top, so we got 1. And then we simplify 16 minus 12, we end up with 1 over 6 to the 4th. And we can go throughout and whatnot. 4, a over b to the 9th when it comes to dividing with two separate variables, in this case a and b. Both of them are going to be raised to the power of 9. So a to the 9th and then b to the 9th. And this is as far as I can go because a and b are separate bases. 5 is the same thing, dealing with same base, so we subtract our exponents. 6, I'll do 6 really quickly because now we are dealing with a multitude of numbers and letters. So we are going to divide like items. So I can divide numbers. So here we can divide 49 by 7. 49 divided by 7 gives me 7. And because I have so much going on, I'm going to put a line here as if I'm dealing with a fraction. So 49 divided by 7 is 7. It's got a positive exponent of 1, so it's going to go on top. Dealing with x's, we have x to the 6th divided by x. Again, technically, we have an exponent of 1 on the bottom x. So we ask ourselves, where is the bigger exponent? 6 versus 1. 6 is larger than 1, so therefore x is going to be on top. And it's 6 minus 1. Top minus bottom. And then 6, or the y's, we see that we have y over y to the 4th. Technically, that 1 on top has an exponent of 1. So y to the 1st divided by y to the 4th. Larger exponents on the bottom, so this tells me y is going to be on the bottom. And we subtract 4 minus 1. And I will simplify. So 7x to the 5th, after doing 6 minus 1, 7 to, or y to the 3rd. Y to the 3rd power. Notice everything is positive exponents. And we go through and we apply all these same rules, divide like terms by like terms. It can get kind of tricky, like in number 9. This will be the last one that I do. I might do 12. Number 9, it gets a little tricky because we have negative exponents and up top, on the bottom. You just want to keep in mind what's going on. So again, we have a lot of stuff going on, so I'm just going to write a line, say I got a fraction. So 9 divided by 54. I can't really get a nice solid answer because it's top divided by bottom. 9 divided by 54. I can reduce though. I can divide both 9 and 54 by 9. So 9 divided by 9 gives me 1. 54 divided by 9 is 6. So I simplified this fraction, 9 over 54, to be 1 over 6. And then I look at the letter c. I have c to the negative 6 over c cubed. Again, I ask myself, where is the larger exponent? Positive numbers are always bigger than negative exponents, or negative numbers. So 3 versus negative 6. 3 is the larger exponent. So this tells me c is going on the bottom. And we have 3 minus negative 6. Again, we're always subtracting what the exponent is, so we're subtracting negative 6. Next up, I see we have d to the 3rd divided by d to the negative 5th. Again, where is larger exponent? 3 is larger than negative 5, so d is going to be on top. And this is 3 minus negative 5. And our last e, we have e over e to the 7th. Again, technically there's a exponent of 1 on the e on top. So I compare my exponent of 7 versus 1. 7 is larger, therefore e is going to be on the bottom. So we have e to the 7 minus 1. And what I'm going to do is I'm going to simplify with the subtraction of exponents. So I don't really need the 1 on top. So we have d 3 minus negative 5. When I subtract a negative, I really end up adding. So 3 plus 5 is going to give me 8. We still have 6 on the bottom. 3 minus negative 6, I end up adding 6. So we have c to the 9. And then e, 7 minus 1, gives me 6. So simplified, we have d to the 8th over 6c to the 9th, e to the 6th. And then number 12, what I'm going to do, and I'll do number 12 as well. Number 12, we have 2x squared y to the 4th, all raised to the 5th. And then we have 4xy times 2x to the 6th, y to the 30th. So what I want to do is I want to simplify to make my life easier. Instead of having all these exponents and multiplication going on, I'm going to use rules of exponents to simplify both the top and the bottom. So the rule is anything inside parentheses gets raised to the power of 5. So this means 2 raised to the power of 5. It means x squared raised to the power of 5 and y to the 4th raised to the power of 5. So anytime I do 2 to the 5th, that means 2 times 2 times 2 times 2 times 2. 2 to the 5th ends up being 32. 2 times 2 gives me 4, times 2 gives me 8, times 2 gives me 16, times 2 one last time gives me 32. X squared raised to the 5th power, I multiply the exponents, raising a power to a power. 2 times 5 gives me x to the 10. And I do the same thing with y to the 4th. Power to a power, I multiply 4 times 5, gives me y to the 20. And on the bottom, I am multiplying straight across. I multiply my like terms. And when I multiply separate bases, I'm going to add the exponents. So here we can do 4 times 2. 4 times 2 gives me 8. I can do x times x to the 6th. So 1 plus 6 gives me x to the 7. And then y times 30. 1 plus 30 gives me y to the 31st. So this is simplified, so that way there I can go through and divide accordingly. So 32, because I have so much going on here, I have 3 different things. I got numbers, the letter x, and the letter y. I am going to create a fraction just by drawing a line, because at this point I don't know where my items are going to go. I don't know if numbers are on top or on the bottom. I don't know if the x's or the y's will be on top or bottom. We just have to go down the line. So 32 divided by 8, I can do that. Gives me 4. 4, it has a power of 1, so it's going to be on top. X to the 10th divided by x to the 7th. The bigger exponent is on top, so x is going to be on top. 10 minus 7. Y to the 20 divided by y to the 31st. 31 is larger than 20, so y will be on the bottom. 31 minus 20. And I will simplify 4x. 10 minus 7 gives me 3 over, and then y is on the bottom. 31 minus 20 is 11. So my final answer will be 4x cubed over y to the 11th. So this is a review on what to do when we are dividing multitude of monomials and what to do with our exponents.